Welcome to Second Nature's webinar on delineating MS4 drainage catchments. Appreciate everyone's time here. So again, welcome everyone. Appreciate you taking time out of your busy days to spend an hour here with us today to talk about urban catchments. So just to go over the brief agenda for today, we'll first be introducing Second Nature, kind of give you an idea of who we are and what we do. We'll then go into some ArcGIS Pro tips, ultimately wanting to help you save time when you decide to delineate your own catchments. And then we're going to go into a to-inform catchments demonstration, showing you how we at Second Nature utilize these catchments within our software. So we are Second Nature as a company, and our software is called to-inform. So we'll go over how we utilize catchments, and then we'll open up for a brief question and answer period. So that'll be kind of the flow for this hour. The big takeaways we hope for you to gain from this hour are ultimately what a catchment is, why they are important, save time, of course, delineating your catchments. All of our time is valuable. And then ultimately the real applications of how to utilize these catchments within your local areas, your local cities and municipalities. You'll have two hosts for this webinar. You'll have myself. My name is Josh. I'm on the science team with Second Nature. I come directly from the municipal side of things. So for the past 6 years, I was an environmental scientist for a local government in Delaware. So I come firsthand bringing that experience of managing a stormwater program, managing the MS4 permit, and also managing the NPDES industrial stormwater permit for that municipality. I also come as a to-inform user. Our municipality is a to-inform user. So I also have that experience as well, understanding the importance of utilizing the software, of utilizing catchments with Second Nature's software. We also have Michelle, who will be on the webinar here in a little bit. She's on the product side of things at Second Nature. She ultimately uses her experience with GIS and applied science to develop new software features. So we'll be hearing from Michelle. She'll be doing the demonstration here in a bit. I've had a pleasure of working with Michelle both on the municipal side of things as well as on the Second Nature side of things. So I'm excited to have her on board, and she's a wealth of knowledge. So look forward to her doing the demo in a little bit. So as promised, I'm going to introduce Second Nature, kind of who we are and what we do. So Second Nature is a software as a service company. We build stormwater management software and embed peer-reviewed literature into that software, so that way the stormwater managers can directly have peer-reviewed literature that gives them the best data possible to track their water quality progress, as well as streamline their regulatory compliance. So this is really a win-win for both the GIS folks in the room and the stormwater folks in the room, because Second Nature's software to-inform, we are an Esri partner. We're backed by Esri. So any GIS professional I've worked with in the municipal level, any software that comes into the door, they love when it meshes with Esri products. So that way it communicates with your local Esri instance. And for the stormwater folks in the room, everybody loves streamlined regulatory compliance because let's be honest, everybody wants to keep their regulator happy. So it's a win-win on both sides. So I kind of want to lead into this with a question of, have you in the municipal level ever wanted to take that data that is gathered by your field crews, that labor-intensive field data from the catch basin cleaning to the street sweeping routes, catch basin maintenance? Have you ever wanted to take that data and analyze it, compile it, synthesize it to make sense of it, right? To make sense of this data so that way decisions can be made at the local scale, and ultimately those decisions can be shared with either your public works director, perhaps city council, or maybe the public at large, and especially your regulator, right? Sharing that data with your regulator and illustrating your program's effectiveness and success. The answer, of course, is yes, right? Everybody wants to do that. That's the goal. When I was the municipal manager, that was the goal, trying to help the public works director see where in the city we can use our financial resources to manage our stormwater more effectively within the city. So that certainly is the goal. And Second Nature has developed and utilized this urban catchments technique that really brings it all together for stormwater. It manages stormwater in a very appropriate fashion. So these urban catchments are basically refined from an urban watershed. So everyone, I hope, is familiar with the term watershed. If not, no worries, we have the picture right on the screen for you. So we'll look at this diagram. We'll start from left to right. We have the urban watershed, which is the area within the black circle. Everywhere within that area is draining, all the surface water is draining to the receiving water. So that's the concept of a watershed. All the water is shedding towards that receiving water. So to get to the urban catchments, we'll go one more refinement to urban drainages. So we'll break up that urban watershed and we will subdivide it into urban drainages. And that is done by understanding where your storm pipes are and where your outfalls are. So here we have the storm pipes, they're the gray lines. We have the outfalls, which are the gray circles. And then ultimately the urban drainages are the dashed lines. So you would delineate these areas, these urban drainages, by understanding where that terminal discrete outfall point is at the receiving water, and then mapping the stormwater conveyance that ultimately feeds to that outfall. That would be considered an urban drainage. So all the stormwater coming through that system go into that discrete outfall at the receiving water. That's your urban drainage. Then you take it one step further to the urban catchment scale, and that urban drainage is now subdivided into about 100-acre parcels, and that's considered your urban catchments. So now your urban catchments really tie the landscape to the receiving water. So those urban catchments are all hydrologically connected, so you can tie the landscape to the receiving water, which is huge in terms of managing stormwater and understanding how you as a stormwater manager and you as your stormwater program are affecting the receiving waters. So all of your structural BMPs that you do, your inspections, the condition assessments, your street sweeping routes and frequency, those catch basin cleaning programs, construction site management, all of these things that you're performing on the landscape scale have an impact on that runoff going to the receiving water. So these urban catchments really allow you to tie those actions that are being done on the landscape and be able to do particulate load modeling to model the particulates that are coming off of that catchment and entering the receiving water. So the screenshot that you see is a screenshot from our 2Inform software and just gives you a brief glimpse. Michelle will go into it more, but a brief glimpse about how we utilize these urban catchments, where it shows you opportunity maps within your city. Where in your city do you have the greatest opportunity to reduce pollutant loads further? So just to give a brief personal example, how I utilized these catchments as a stormwater manager, I utilized them to help us be more competitive for surface water matching planning grants within our state for green infrastructure retrofits. So we partnered with an engineering firm that assessed throughout the city where green infrastructure retrofits would be most appropriate. And then I would take those locations and essentially overlay with the opportunity maps and kind of see where they aligned. And then we're able to take that information to the director and city council to really pitch a case for, these areas we really have opportunities to reduce our pollutant loads to the receiving waters, and we can do that through these green infrastructure retrofits. So just one example for me, how I utilized these catchments, and it kind of transformed our stormwater program. But enough of me talking. I'll be ready to pass it over here to Michelle, and she'll give you some more in-depth ArcGIS Pro tips, as well as some demonstrations on how to do this. So some of the things she'll be reviewing is utilizing the Living Atlas, taking advantage of existing local data sets, the ArcGIS Pro's split and merge editing tools. Those are a huge time saver. And then ultimately toggle between imagery and topographic base maps. So this is kind of the things that Michelle will be outlining. So Michelle, I'll turn it over to you.
Awesome. Thanks, Josh. And hi, everyone. So happy to be here. And yeah, I'm excited to show you all some tips on how to delineate catchments in ArcGIS. And while I'm bringing up my GIS screen here, I just wanted to mention that it looks like there's a good mix between GIS professionals and stormwater professionals. And so whether you're on the GIS side or the stormwater side, these tips are going to be relevant for both parties. All right, so I am sharing my ArcGIS Pro here, and I'm going to dive into tip number 1. So tip number 1 is to utilize the Living Atlas that's built into ArcGIS Pro. I've got a blank map here, and staring at a blank map can be really, really daunting, especially when you might be starting from scratch on catchments, or you're just kind of diving into GIS. A blank map can be kind of defeating. And so the Living Atlas is a really great repository of national scale authoritative data sets that's hosted by Esri. Various organizations can contribute to it, and you can actually pull those data layers from the Living Atlas directly in ArcGIS Pro. So to find the Living Atlas, we can go to our catalog pane right here, and we can click on Portal. And then in this portal menu here, there's an icon for the Living Atlas. I can click on that. And this allows me to query all the data sets that are in the Living Atlas directly in ArcGIS Pro. And so since this webinar is all about catchments, I recommend starting with 3 data layers for catchments. So the first data layer is use and query for some kind of watershed boundary data set. If we want to talk about our goal is to delineate these small scale, accurate drainages that identify where stormwater is routed throughout your MS4 and ultimately discharged into the receiving water. So in order to do that, it's really, really crucial to understand where existing watershed boundaries are. And so we can query the Living Atlas for a watershed boundary data set, and there's a few options. So I will go to this one and right-click and add to my map. This data set that I'm showing here, this is actually one that's created by the USGS. So again, it's a reputable source. It's maintained by the USGS, and I'm able to pull in their data layers automatically into ArcGIS Pro. And so using these watersheds will be a really great starting point in terms of being able to better understand the hydrologic context. And I can actually use these watersheds to subdivide into urban drainages and eventually urban catchments. And I'll get to that later in my demonstration. Okay, so we've got our catchments here, or our watersheds rather. And so the next data layer that I recommend using in the Living Atlas is a type of water body data set. So understanding where our streams and our rivers and main water bodies are. Again, because these catchments are defining areas that drain to receiving waters, we can't really do that well unless we know where those actual receiving waters are. So in my query for a watershed data set, I actually see down below here that there's a national hydrography data set. So I can go ahead and right-click and add this to my map as well. And now I've got my watershed boundaries. And if I zoom in a little bit, I can see lines that show me where all of the major streams, tributaries, lakes, and even oceans are. So right away, I'm already adding to that hydrologic context. I'm starting to better understand where my main watersheds are and where I can start to actually subdivide my watersheds that will eventually take me to my urban catchments. And then the last data set that's really, really helpful, again, when you're starting from scratch and wanting to delineate catchments, is some type of elevation data set. So if you're a GIS professional, you're likely really familiar with different types of elevation data sets. Those can be DEMs or digital elevation models. It could be a slope layer, or it might be a line layer of contours. And I highly recommend actually reaching out. So if you're a stormwater professional, making sure that you reach out and collaborate with your GIS team, because they will most likely have a local high resolution elevation data set that you can use. Elevation is going to be really crucial in these beginning parts of identifying where these drainages are. So highly recommend looking at a local data set. However, if you're crunched for time or for some reason you can't find the data set that you're looking for, we can always use the Living Atlas. So we can query the Living Atlas here. I'm going to look for contours because contours are really helpful when I'm trying to understand watershed boundaries. So I've searched for contours in the Living Atlas. There's lots of options that appear, and I'm going to select this world contours layer down below here. So now I've got my watershed boundaries, I've got my streams and my receiving waters, and I've also now got contours that visualize the elevation changes in my area. So right away, I've already got really good context on the kind of local topography and hydrography, and I didn't have to download any data sets and re-upload them. They're all available in the Living Atlas. And also, depending on a layer's permissions in the Living Atlas, you can also take these data layers and actually export them to your own geodatabase. So you can add attributes or edit attributes. So depending on that, I highly recommend kind of just exploring the data that's available in the Living Atlas and seeing what you're able to extract and add to your own geodatabases. Okay, so that's tip number one. So now we've kind of got this baseline, 3 data sets that help us better understand the local landscape. So that kind of leads into my tip number 2. So tip number 2 is to use any local data sets that you already have at your MS4. And so this will depend, of course, on your GIS capabilities and where you are in mapping your MS4, but more likely than not, you will have some kind of stormwater infrastructure likely mapped in GIS. So this could be anything from outfalls to stormwater inlets to pipes and open channels. And even if these data sets are not complete, or maybe they're a little bit outdated, that is totally fine. Using any of that information is way better than not using it at all. So to demonstrate how you can use your local data, I've pulled in some data in this area. And so we can see here that I've got some outfalls mapped, I've got storm drain pipes mapped, and then I've also got my receiving waters mapped. So these are things that in my MS4 here, I've identified, I've already got mapped from previous projects or work that I've done. And so a few tips on maximizing the use of your existing data. I highly recommend taking some time to explore the attributes of these data layers. You'll notice that in my outfall layer here, the sizes change. So I've got some really big points and some really small points. And so what I was able to do is kind of explore the different attributes of my outfalls. And I noticed that I had a diameter field. And so I used that diameter field to symbolize the points. So the larger circles are going to represent larger outfalls. This becomes really helpful because larger outfalls usually mean that they're draining larger areas. And so these become the good a great starting point on where you might want to start delineating catchment boundaries, especially if you have a big MS4. It can be kind of daunting trying to figure out where you want to start. So recommend starting at the big outfalls and kind of working upstream from there. You can use a similar method at displaying storm drains the same way. So again, I've identified a diameter field here, and I've symbolized the lines by diameter. So the thicker lines represent those kind of main open channels or canals for stormwater, where the thinner ones are maybe tributaries from developments. So, and all of that was just using the existing data that I had. So highly recommend taking a minute, chatting with your GIS team if you aren't as familiar with the data you have, and exploring it and seeing what you can use. All right, so that leads me to tip number 3. So now we've got our contours, we've got our watersheds, maybe we've got some existing data that we can use. Tip number 3 is to use all of the awesome editing tools available in ArcGIS Pro. Now, I'm not going to have time to demonstrate the full editing toolbar in ArcGIS Pro, but I do want to demonstrate the power of using the split tool. And I'll show a few applications depending where you are in your catchment delineation process. But before we do that, let's go back to our definition of a catchment. So a catchment is a small-scale, accurate drainage of how stormwater is routed through the MS4 and then ultimately discharged to an outfall. And multiple catchments make up multiple urban drainages, which make up urban watersheds. So you can kind of think of it as this stacked kind of Russian doll analogy. And if you're just starting out with delineating catchments, you're likely going to be still at this watershed scale. And so one way that we can use the editing tools in ArcGIS Pro, and essentially the split tool, is to actually take these watersheds that either you've pulled from the Living Atlas, or maybe you have your own watershed dataset already created. And we can use the split tool to split these watersheds into smaller drainages and then ultimately catchments. So while splitting a watershed doesn't necessarily mean it's a catchment right away, it's a really important precursor to delineating catchments. And so I can demonstrate how I would go about that. So I've got a watershed right here. I've already selected it, and I'm going to turn on my contour map right here. So to find the split tool, there's an editing toolbar in ArcGIS Pro. So you can click on that. And then I've got in this tools pane right here, I've got my most used tools, and I'm going to click on split. Split is definitely the most used editing tool, especially when I'm delineating catchments. And the way I use this is I'll zoom in a little bit, and I'll start by creating a vertex outside of the polygon that I've selected. And then because I have my contours handy, I'm going to use these contours as guidelines on where the subwatershed boundary should be. And there's lots of tips and guidance online if you've never delineated a watershed. Basically, you can use contour maps to help guide where you need to draw that boundary. So I'm going to follow these contours and basically draw a subwatershed for this one tributary. And so you'll see I'm adding points. And again, using the contours as a guideline. And then when I'm ready, I'm going to create my final vertex, again, outside of the polygon that I've selected, and then double click. So there you'll see that it flashed, and now I actually have two separate polygons. I have the original watershed one that I had pulled in from the Living Atlas, and now I have this new subwatershed that I created just by using the split tool. So this becomes really powerful because it minimizes any slivers that you might create from trying to hand draw these, or gaps or overlaps. And so highly recommend, again, using an existing data set and then using the split tool to help kind of subdivide these into drainages and catchments. So that's a really helpful tool if you're starting from scratch. If you are one of those folks that may already have some form of catchments delineated for your MS4, but maybe you want to work on refining the boundaries to be a little bit more accurate, you can also use the split tool for that. So to demonstrate that, I've got some example catchments in my city right here, and I'm going to zoom in, and I noticed that this catchment right here, turn off my watersheds. This catchment right here, it looks like it should be following along a road, but instead it's kind of bowing in and almost overlapping with this storm drain pipe. So I want to fix that. And one way I can quickly fix that is, again, by using the split tool. So if I've actually selected the adjacent catchment here, and I'm going to go back up to my split tool. And then again, I'm going to create a vertex outside of my catchment. And then I'm going to trace along this road here. So this is where the catchment boundary should be. It's following along this road. And then I'm going to create a vertex on the outside of that catchment. Double click. So now I've got this sliver right here in between my original catchment and my adjacent catchment. And so what I'll do is select this new sliver that I just split, select the catchment that I want to merge, and I'm actually going to use this merge tool in the editing toolbar. And what this does is essentially take these two geometries and it's going to merge them together. So once I click that, now I've got a nice clean straight line that follows the road where the catchment boundary should be. And again, I haven't introduced any gaps or overlaps, and I've been able to quickly do this just using an editing tool in ArcGIS. So highly, highly recommend, whether you're starting from scratch or if you have an existing layer that you want to refine, checking out the split tool and the merge tool in ArcGIS Pro. All right, so now we've got our basic outlines, we've got our streams and our watersheds, we've got our local data sets. We're working on refining our boundaries. That takes me to my last tip, tip number 4, which is to make use of all of the different base maps that are available in ArcGIS Pro. One thing that I've noticed is when I'm really deep in the trenches of trying to maybe refine some of these boundaries that cross roads or go through neighborhoods, it's actually really helpful for me to look at this topographic map. So looking at the contours, but then once in a while flipping back and using the imagery base map in ArcGIS Pro. Imagery can be really helpful because it kind of brings that local context back to your catchments. Which neighborhoods are draining to which storm drains or which receiving waters. And it will help you kind of, bring everything back, because you can get kind of lost in all of the different contours and lines. So I've found it really helpful to kind of zoom in and make sure that it makes sense, land use wise, planning wise, and of course, hydrologic sense. So I tend to flip back between this imagery map and using maybe a USGS topographic map that can sometimes be really helpful because it has higher resolution contours. So just recommend playing around with your base maps. They're really, really helpful to give context on different types of information. So those are my 4 tips. Again, use the Living Atlas when you can to pull in national scale data sets. It's really quick and easy to query and kind of just explore what's out there. Of course, use the data that you already have available to your MS4. Make sure that you're in contact with your GIS department, understand what they've got already mapped. And if you are in the process of refining or creating boundaries, make use of the editing tools. These are super powerful. I use split and merge, again, all the time. And then lastly, make sure to toggle between different base maps to make sure that you're understanding the context of where these catchments are. And so now that I've demonstrated some of these technical hands-on tips in ArcGIS, now I want to switch gears a little bit and show you all some real-world applications of how these catchments can be used. And so to do that, I'll be jumping into Second Nature's software platform, 2Inform. So I'm sharing my screen right here, and I'm showing Second Nature's software platform again called 2Inform. And 2Inform is a modular stormwater management software platform. And it uses a geospatial architecture to help our municipal customers inventory, track, and manage assets that are related to stormwater programs. 2Inform is also able to produce things like automated reports and analyses and dashboards all around stormwater program effectiveness. And so right now I'm sharing the landing page to our software. And you'll notice that each one of these icons at the top is a component or a module within the software. And if you are on the stormwater side, you're likely familiar with a stormwater permit. And you'll probably notice that this first row here, each aligns with a minimum control measure within your stormwater permit. And these second and third rows here are all designed to help your program's efficiency and data integrity. And then on this left-hand side here, we've got icons for annual reporting and program impact evaluation. And so the really great benefit of using 2Inform is that the reporting and the analyses are entirely automated. So as you enter data into these data management modules and you do your daily and monthly inspections, we're able to produce automated map and chart summaries, dashboard views, and we can even estimate pollution reductions from BMPs, which Josh alluded to in his introduction. So let's go into our structural BMP diagnostics module first, and I'll demonstrate how we can use catchments in this application. And for a little bit of background, the structural BMP module here is really designed to help you map, classify, and also routinely inspect all of your structural assets. Terminology can vary across the nation. We're calling them structural BMPs. These are oftentimes called control measures or structural control measures, but essentially this tool helps you manage any kind of asset that's designed to treat or retain stormwater. And so here you'll see that the main focus of this tool is a map of an MS4. And like a typical GIS, I've got a legend on the right-hand side, and I can start to turn layers on and off. So I've got my outfalls here, I've got my streams, and I'm actually going to turn on my structural BMPs since we're in the tool that's where I can actually manage these. And so what we can do here is not only use this tool for our kind of day-to-day data management, But you'll see on the left-hand side here, I've got a sidebar that shows receiving water. And then as I hover over these names, it's highlighting the map in yellow. And if I click on one of these names, it's going to query and filter the map. And then you'll see that I have polygons highlighting in yellow as well. So these are actually the urban catchments and the urban watersheds that I've delineated in GIS. So I can use that data layer to add a little bit more context to the data that I'm managing on a day-to-day basis. I can use it to query and understand what assets are treating what receiving waters. I can better understand the condition of all of my assets by receiving water, but really help to link the urban landscape to these local receiving waters. So I could pick out maybe a few structural BMPs or assets here that might need attention. I can look at their past inspection results, and all of it again is tied back to that catchment and watershed context. Now, the other way that 2Inform uses catchments is also in our annual reporting and program impact evaluation applications. So I'm going to go into my annual reporting tool here. And like I mentioned in the beginning of my demonstration, as you add data in your other modules, the annual reporting will do all of the summarizing and analytics for you. And one of the most powerful components of this tool is the pollution reduction modeling. So I'm going to demonstrate what that actually means. So 2Inform is able to pull in historical rainfall data sets, local land use maps, soil maps like the one I'm showing here, impervious surfaces, and connectivity data. And we're able to take all of that information, aggregate it together, and use it to estimate baseline pollution loads. And what baseline pollution loads means is that you're looking at the landscape as if there were no BMPs in place. So as if you had no control measures or street sweeping programs in place, what is the estimated amount of particulates or volume that runs off the surface into the local waterways? And what we can do is aggregate all of that modeling data and summarize it back to the catchments. So on the map right here, I'll expand the legend, but what we've done is actually shown the modeling results and colored the catchments by its relative particulate loading rate. So the darker catchments are going to be these catchments or these areas that generate the highest amount of particulates or stormwater runoff. And what I can do is, well, I have the total estimated particulate load down below here. And then I can actually, again, use my watersheds and my catchments to query the results. So now I can see for the Watsonville Slough here, I've got a baseline particulate load of 120 tons per year of sediment. And I can actually drill down even further and show it by catchment. So I'm starting to really tie all of these BMPs and modeling results back to that hydrologic and watershed context. But like I mentioned, this is just for baseline. So assuming that there's no BMPs in place, which is not really reality. And if we go back to that structural BMP module that I was showing, we know where those assets are. We can map their drainages. We know their condition and what type they are. So we can actually use that information in our model and help estimate pollution reductions from our practices and from our BMPs. So what that means is I can go to this tab here, and now instead of showing this baseline load, I can kind of show the flip side. I can show which catchments have the highest implementation of BMPs and which ones are reducing the highest amount of particulate load. So now these darker catchments, these are the ones that have the highest reduction. And if I'm interested, again, I can use the map to kind of drill down and query and understand how I'm achieving those reductions. So I can look at this individual catchment and see that almost 80% reduction is due to all of my structural BMPs in place. So these catchments and these maps start to become the crux of how we're able to easily summarize all of these complex modeling results and communicate our stormwater program's effectiveness at reducing pollution and also better understand our MS4's impact to the community. So catchments become a very vital part of understanding and communicating your stormwater program's impact. And with that, that concludes my 2 demonstrations. If you have any questions, throw them in the Q&A, and hopefully we'll have time to answer as many as we can at the end. But yeah, I'll pass it back to you, Josh.
Yeah, thanks, Michelle. Awesome job. Awesome. Yeah, thanks again, Michelle. As I said, you guys are in for a treat with Michelle. Wealth of knowledge. So awesome. Thanks again. So yeah, briefly, the 4 tips that she went over: the Living Atlas, take advantage of existing local data sets, ArcGIS Pro split and merge tools, and toggle between imagery and topographic base maps. Wealth of knowledge indeed.
Thanks everyone for participating.